Hello, we're going to slot something in today which wasn't planned. I did mention that we got another Amstrad 901 to service. Because if you remember, a few days ago, a customer of ours sent an Amstrad 900 in, which was excellent, and a 901, which was excellent. We had to do the ballast resistors on both. 900 I had to swap the speaker on. So somebody contacted me through the email and said, could I sell them an Amstrad 901? So I had a look round, and we got 4 genuine made in Japan ones, and this is one of them. You can see it uses the early type of connector. So because our friend Gareth in Leeds 3D print, he designed and 3D prints these for us, we can do that. So that will plug in nicely just like that. So we've got that. It'll come with a new bracket, which is, these are available from Brickworks. They are, I'll put a link because they are, we've sent samples over of when we've got brackets so they can have them copied, and these are made in Sheffield. So there you go, it's the real thing. You get some British steel there. So it'll go out with one of those. We'll be doing this on I might have a microphone which says Amstrad on, but we'll come to that later on. So this has been serviced by the trade. I've sent 4 photos and I put the serial numbers on them, and they've got different colour stickers on because we have a red, amber and green traffic light system as to whether they've been serviced or not. This has been serviced by somebody else in the trade. And it's been bought as a working set. So here we go. We'll pop it open before switching it on, just in case there's something funny, but I say it's come as a working set from the trade, so it should be spot on. Usual thing, if it's doing 3.6 watts or above, then it can stay with its ballast resistor. If it's doing 3.6 watts or less, then we'll change the ballast resistor. So I'll temporarily take that off. Can't see any shenanigans. Bit of a long leg there because somebody has changed the ballast resistor, but we'll have to check that it's a non-reactive one, because sometimes we can end up with wire wound ones in which aren't ideal. This is one with a wire wound one, so we'll swap that straight away. Right. It can affect other things in the transmitter, so that's just one of those no-nos. We've got these. I'll do this before we start. We've got 2 left. And of course I ordered from this firm yesterday, so and of course there's a minimum order, so we used to have a cork board on our DOS computer system, but we only have one DOS computer with it's not networked these days, so of course I don't see all this. Right, get that changed. Let's see if we've actually got some solder on here as well. I'm not going to adjust anything, I'm just going to change the resistor. So the ones of choice are these, which are 6 watts. I mean, that's fine with its rating, it's 5 watt rated, but you're not really supposed to use that type. So I'll put the piece of Sister Flex on there. again we'll have it mounted higher than they were originally. Go over that with isopropyl alcohol later on in the proceedings. Make sure we've not got anything sticking out. So as a temporary measure, I'll just put this case back on with one screw because of the capacitive effect. And now we'll connect it up. So originally these had 2.5 watt ballast resistors in, and you're hard pushed to get anywhere near 4 watts, as you can well imagine. I get the impression Amstrad had a problem with the first shipment where the inspectors had found the first set they sampled something to be like 4.01 watts and the whole batch was rejected. So I think they had to, those ones with the skinny resistors, they had to add an extra one in at Amstrad, you know, like 2,000 of them or something like that. So everybody was doing it, the secretaries were doing it. Right, to get it connected to our test equipment, I'll start by connecting the PA speaker. So once again, for people who aren't aware, there's other versions. This is the early one from November 81. It's got this funny socket which we've only recently been able to do anything with. Normally it's the square round socket, which is the normal one, but very early production it's this, and this would have been the one which had the 2 skinny resistors, as I was saying about the batch being rejected simply because they were over power. So then you've got the Hong Kong version with the screen printed board, which is a cheap version. Presumably fake, because Alan Sugar in his book never mentioned having a second batch made. And then thirdly, you've got the made in Hong Kong with a non-screen printed board. It's a bare board with no component locations. They were £29.99 new as against £89.99 new. You get what you pay for. And so of course everybody says, oh, Amstrad CBs, they're crap they are, but they'd all got the fake ones. It's like saying, oh, I've got a Calvin Klein t-shirt, and you bought it off a market store for 99 pence, and then it falls apart in the wash. You go, oh, Calvin Klein t-shirt, they're crap, they really are. You haven't had a real one. Anyway, I'll go and get a mic. Nothing changes, does it? There's still fake everything. Not quite sure where I've put the test mic on the Binatone Route 66, which we're nearly finished. Right, switch on. So we're on channel 20, it's in receive, let's go to public address. Testing 1 2, testing 1 2, Wally. Right, so that's one thing working. Did hear just a little crackle there, it's just put some switch cleaner on the volume control, especially if I can see where it is. Testing 1 2, testing 1 2 1 2. Testing 1 2, testing 1 2 1 hello 1 2. Right. Because the Route 66 is on top of the clipboard. So here's what I sent this photo of this set and the serial number, and so that's the set we're working on. That's the plan. So it's 26939. 26939, 12th of September 25, Amstrad 901, Japan. So I've shown all three versions of these in the past, and to be honest, the cheaper $59.99 one, the Hong Kong one with the screen printed board, works the same. To my experience, it works the same. It might not be as reliable, but it works the same. The problem is the cheap one, the $29.99 one with the non-screen printed circuit board. The squelch, you've got to manipulate the RF gain for the squelch to work. It's just the way it is. So you get what you pay for, don't you? Except some top price items, which is just a rip-off. Right, so here we are. It's going to transmit. So we'll have to adjust that. It's 4.2 watts. I've changed the ballast resistor, and that's going to have changed that. Channel 1. Channel 40. $220 milliwatts. That's a bit high. Right, deviation is probably right, but we're going to put it through to our test set behind anyway. Wow, it's showing 3.5 on here, which isn't good. But there you are. VCO, that is important. Let's go to channel 1 and make sure it's set right. Don't want channels dropping out. So, meter, we're looking for you know, if I wasn't showing these on a video, I'd be using a Keithley Auto probe multimeter, which is a probe with a LED on the top. They're 1980s, they're hundreds of pounds, because I like it, but I can't show it on the. I have to use an ordinary multimeter. We always use this cheap one because we're not building a spaceship, and the point is the accuracy is good enough for what we're doing. So if I put on a £100 meter instead of this £16.99 meter, the results will be exactly the same in this situation. But we do have true RMS digital multimeters. We've got AVO 8, AVO 7, AVO Mark 40. I think we've got a Simpson one. We've got electronic analog voltmeters and so on. You know, we've got quite a range of meters. But the meter of choice, the whole point about this channel is to show people things which are attainable and not with elite equipment. Says he using a test set that is thousands of pounds, but they can be had for, you know, like 700 second hand. Right, so it's there, and we're looking for 2 volts. It's 2.1. We're going to transmit. It's 2.15. Go to channel 40 to check some. It's supposed to be somewhere around there. It is, and it's supposed to be somewhere around there, and it is. So 2.1, which is very important on this chassis. Test gear's not been on very long. I'm sure it's going to be over 100. So it's supposed to be 2779125. Let's have a look. I can set it now, but we'll check it at the end when everything's. Come on, channel 40. 79109 is absolutely fine, even if it didn't go any higher. 2779109. Of course, it should be 2779125. If you get lower than 076, it starts to become noticeable. If you go lower than 026, that way kind of way, it starts to become illegally out of tolerance. They drop with age, and it's 40 years old. Right, that's covered all that. What does the meter say on transmit? It's supposed to be 4 lighting, it's 5. So we'll put it down as full scale deflection, but the power's too high anyway. Now I've changed the ballast resistor. It doesn't have a meter lamp. Switches work. The volume was noisy. Corrected. Sockets work. PA work. So that's gone through those. I'll put the signal generator on, and let's have it on 2779. What was it? 109. So on sets like this, where you've got a single adjustment for the frequency, you want when you're setting up a signal generator, you want it to match what the radio is doing, not what it's supposed to be doing. Otherwise you end up with a lopsided receiver. (791) There we go. So we're on frequency for the receiver. Let's plug our test gear into the extension speaker socket. Right. So at the moment, on this early version, we've discovered only recently, if you adjust the squelch after you've adjusted the meter, you end up with the wrong S-meter reading. I think what's happened with the other engineer there. So at the moment it's reading 5, it should read 9. So we'll correct that and then correct the squelch. I'll just do that now. So we've now got 9, but it will alter when I do the squelch. It doesn't tell you to do it in a different order to what we've always done, but on this version they seem to be interactive between squelch and the S-meter preset. Right, so let's get a reading of where we are. It's better switch some more test gear on. Go over to the SINAD meter. It's so good, I inadvertently went to the lower scale. 0.27. Somebody put a comment that they had an Amstrad 901 before upgrading. I find that interesting because the performance can't really be bettered. You know, there's one or two Binatone 5 stars and Rotel 240s using the posh version of the Cybernet 134 chassis, which will do that little bit better on receive. But I can't think there's any. I don't know what feature you want that's better. So here we are. 0.61. I think there's a problem here that people associated Amstrad with some lo-fi equipment. There's nothing to do with Amstrad, they just bought it in. Cybernet radio. So it could be a NATO 40, it's the same innards. Could be a Mustang 3000, it's the same innards. Could be a Harvard 420M, same innards. Not 420M, sorry, 402 MPA. Could be a Harvard base station 404, same innards. It's a very competent chassis and it's nearly all Sanyo parts. I think, I don't have any proof of this, I think Cybernet was owned by Sanyo. And I say that because why would they put in the LA1230 FM subsystem, which is a Sanyo thing, designed for FM tuners, and then its squelch is used. It has built-in squelch because on stereo FM tuners, on the higher end, it's desirable to have what they call muting. So when you're tuning around, you're not getting the FM hiss. Well, that's squelch in communications, and so they use that muting circuit as the squelch, and it works all right unless it's the fake version. So, you know, I think you wouldn't normally do that. You'd normally use the Motorola MC3357, but on the other hand, you're in Japan, why would you buy an American part? You wouldn't, would you? You'd try and source from your own country, hence the Sanyo chip. Cybernet 134 chassis, it's another, I've forgotten what it is offhand, it's another FM subsystem chip, and it isn't a Motorola either, so I wouldn't be surprised if that isn't another Sanyo part. So you've got a Sanyo audio amp, haven't you? And you've got it's a Sanyo synthesizer, and I bet everything else in it is. Right, we've done that. Let's just check squelch. Full squelch. Bit heavy. Let's turn that down. It is 25 millivolts. Does open at least. 25 millivolts, and in its most sensitive position, let's turn the squelch down on the radio. Set threshold. We're straight in at 0.3, which is excellent. Right. Go back to the main meter, start the tune-up. So I'm not expecting to have to do anything except turn the power down a fraction. So we're going to make sure it's just in the centre of the band. So here we go. So centre of peak, centre of peak, along key, so the set's got chance to cool down, because only about 3% duty cycle like any other CB radio. That wasn't quite in the right position. And then the actual power is set on this final one, and that does need heating up. I'm only heating up the actual ferrite and hoping the heat from the soldering iron transfers to the wax or the grease I've used to make it a bit more sealed than it would be if it was flopping around. There we go. We're tuning down, not tuning up, we're tuning down, so it's clockwise, and we've got exactly 4 watts there. So let's check what we've got on the other channels. They want it to be within 0.1, so we've got 3.9 on channel 40, and we've got 4. I'm just see if we can make that a little bit more. Just see whether that's helped. I'm going to have to do some jiggery pokery here because it's not balancing as well as I would like. Usually that airspace coil, or that one, just turn that, it's now gone up a fraction, just turn that down to 4. Channel 40 is, I think we need to put a kink in that one. No, we don't. We want to actually move it slightly. The placement of those airspace coils is absolutely critical. Right, channel 1, 4.1, channel 40, 3.9. So that's balanced that better. What's that brought our current consumption to? 1.273. Yes. So I think we've got that one in the wrong position. It just shows, getting the SWR right into stage, which is what we're having by tuning it, it makes such a difference. Let's turn the meter off because it's growling at me. Put that away. Low power. Have we got? It's preset on these. It was 220 milliwatts before. It's now 310 milliwatts. So that tuning has helped. I'm going to do deviation next. We'll go through to our test set behind me. Sometimes this Marconi one plays up because the capacitors need doing in it. Right, I'll just do that. Well, it's a little high at 3. That's now correct. Then out of interest, we've got to put it back on the Marconi test set because I like to know what it's playing at today. It's the only test which isn't right on the machine. There we go. Let's see what it says. Well, it's saying 3.2, so it's lying today. So it was 3.0, it's now 2.2 with a peak of 2.5 kilohertz. Now before we do the receiver, I'll just check where we are on transmit. 79103. I'll just drop that exactly. And here goes. So I want 100 microvolts on the test set. We're going to look at the oscilloscope and set the detector. I want enough volume for a sensible trace, so rather than fiddle with the oscilloscope, it's easy to just change the volume. It's just connected across the extension speaker. It says it's a 10 meg oscilloscope, but I don't care if it's a 1 meg oscilloscope. All we're looking at is audio. There's the detector. That tool doesn't want to fit, so let's try this one. That's better. Yeah, slightly out. Okay. What we're going to now do is drop the signal. I'm going to do the intermediate frequency. I go over to the SINAD meter, but I'm actually looking at. We're going over to the SINAD meter. We really are. Yeah, there we are. What I'm looking at is the oscilloscope and that SINAD meter, and also the LED meter on the front, because I need to make sure I'm the right side. You can end up with the wrong side, so the meter on the front can be a guide. Start with that one of the wiring harness. This can get fiddled with because people mistakenly think it's the detector. Well, I can't get that tool to fit properly, so what about this one? Yeah, this one fits in there. That seems the right position. The tiniest movement on that. So a little tiny change. So now we'll go to the front end. We'll drop that to about 5 dB. Whoops, the squelch is on. And finally that one. And now the moment of truth, is it better or worse? Bearing in mind I had to adjust the detector. So for 12 dB, got 0.24. And I just don't see modern sets, very few, anywhere near these kind of figures. I keep mentioning that dreadful Cobra, the very swish looking one, 29LXE, whatever it is, and it's like 1.2 microvolts. It's 2.1. We did that Binatone long range of 40 walkie-talkie the other day, and that's about 1 microvolt, you know. And it's kind of what you expect on a 40-year-old walkie-talkie. 0.56. So now we'll do the meter again, because we did it earlier, didn't we? Because it will have changed, and it has. It now says plus 30. And then we're going to have to check it again. So I've got that to 9, which is where I want. If we increase the signal, we get plus 30. That's what I'm aiming at. I'm not aiming at dropping my trimming tools on the ceramic tool on the ceramic floor. Squelch. So I'm going to put squelch to full, and I want the squelch to now be open because we've got a 100 microvolt signal. There we go. Now, is it working how I want? It is. Let's look at it at the bottom end. That's excellent. So we've now still got 0.3 microvolts at the sensitivity end. We've now got 100 microvolts instead of 25 millivolts. Or was it? I think it was 2.5 at that end. So we now need to just check the meter still says what it did. It's slightly altered, you see. Very, very slightly. Right, so that's reset again. So we've set the meter 3 times. I say there's a bit of interaction on this particular version. And I've not realised that till recently. Every time I do an on-the-air test, the meter's been reading low. It has been set, but when you set the squelch, it affects the S meter. So we've now reset that to read S9, so that's correct. We want the power meter to read 4 watts. I'm just going to check it still is 4 watts because the set's now cooled down. Well, I would have done if I put it back on full power. It's a fraction. I'll leave it at that. And it is camera 1. We'll just need to just pop a bit down on that. Right, so we want the meter to read 4, and it does. I have no need to touch it at all. Transmit, we'll read 4. So on low power, the meter should read 1. The meter reads 1. So that needs no touching, it's the preset there. That's put itself right. So I said this was from the trade, and apart from that wire wound resistor, it can just cause some shenanigans having a wire wound one of that type. So I'll leave this on for now. We'll do the frequency. I'll come back and I'll go and have my dinner. I'll go and find a mic. And we'll leave that on. Okay, so now later, here we are. Just check the frequency, 27.79118. Very close. Finally, we'll just go through to our walkie-talkie, which I'll change to channel 20. Check that Roger Bleep works. Testing 1, 2. Yep. And then we've got the mic it came with, rather than our test mic. It's branded for something not available ever in the UK, but this is the right type of mic. Look at what if there's an anomaly with that plug. Yeah, the screw's missing. We'll see whether this mic's compatible. Testing 1, 2, testing 1, 2. Yes, it is. Right, well, what we'll have to do is to... there was a time when Knights at Curtin and Lindsay had the teeny weeny screws that that fit these, and I might have one in a wristwatch kit. I think we'll have to take off the outer thingy, the outer shell. I think somebody's run glue in that, you know. I'll pause the video while I look into it. Right, I managed to dismantle the plug and get the whatever was in there out, and so we'll put the plug back together. Got the wristwatch selection of screws out. So that needs to go in there. Hopefully that's the right screw. Don't tell me I haven't lined this up properly. Back to spending more time on the microphone, which we don't fix, than trying to save the guy money, you know, and spending mine to save his. It looks like they're lined up. Why on earth is that not going in? I'll tell you what I think. I don't think this shell belongs this particular plug. I think we're wasting time. So in that case, it's cheaper for me to swap the plug. If I can't screw this together properly, just put it together one more time. Bayonet bit to bayonet bit. Twist it. That should be the hole, but the hole is right there on the edge. I can just feel it with the tool. So it's not the compatible pair. We'll assume they're the standard colours you'd expect. Right, I'm going to get another plug out to stop. Alright, we've got the new plug on there, and with, of course, the screw. Testing 1 2, testing 1 2 3 4 5, testing 1 2 1 2. That's it then. Put the lids on. So really, all I've done is to do a bit of a super tune on a set that was trade working. Changed the ballast resistor because the one they'd chosen to put in I didn't feel was compatible, but that's me. Got a full 4-watt output. We've managed to improve the receive. Got 0.24 microvolts out of it. Right, I just need to take that screw out I put in. Especially if I can find a screwdriver that goes with it. We'll get this booked in for an on-the-air test on Tuesday. I haven't got Mr. Chippy today and tomorrow, as it's Saturday today. Right, turn the test gear off. I may as well go with the mic it's going out with. One and a Roger. They'll be 35 miles away. There you go, Amstrad 901, genuine, for a specific person. I've only got another 3 of those to do, and we'll be fine. I'll keep intermingling them. Don't know whether we're doing that Uniden base station next, or whether we're doing the DMT Scanner 40. I've got some on the air tests to edit and get those published as well. So there we are. Thanks for watching.